Hello everyone. Today we are going to go through beautiful binary string, which is a problem on the string section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So here is the problem statement. Alice has a binary string. She thinks a binary string is beautiful if and only if it doesn't contain the substring 0, 1, 0. In one step, Alice can change 0 to 1 and vice versa. Count and print the minimum number of steps needed to make Alice see the string as beautiful. So basically what we are supposed to do here, we have a string as input, and we need to evaluate the number of operations we need to perform on the string to make it beautiful. So if the string contains 0 substring of this, then it is already beautiful. Otherwise, we need to transform it to make it beautiful. And one important thing to know is that we need to return the minimum move required. Okay, let us take some example. If you have, for instance, 0, 1, 0, then for such an example, we need to return 1 because we can either change the first one into 1 or the second one into 0 or the third one into 1. We are going to have the result. But the thing is, actually, we need to organize ourselves to perform the changes in such a way that it will result into the minimum number of changes. Let's take, for instance, this substring 0, 1, 0, 1, 0. We can see that in this substring, we have two sequence of the substring that we don't want to have in our final string. So if maybe we replace this, maybe we replace this to remove to kind of erase the first substring of 0, 1, 0, and we will still find ourselves with another substring here, and we may find ourselves needing to change this like this result into 2 operation, whereas it is indeed possible to have that in one change just by changes 1 year. So what is the trick? How are we going to organize ourselves to perform the changes such a way that we can really find ourselves with the minimum move required? So the idea will be to change the last element of a matching substring with 1. Why are we using that? Because if you change the last element of a matching substring to 1, you ensure that that substring or no character of that substring can be reused for the next part of the string. So that is basically the whole idea about how we are going to implement this. So what we are going to do is that, okay, we are going to loop through the string, and if a substring of 3 elements is equal to our substring that we want to avoid, we then count it as, okay, 1 operation we need to perform. And if you perform an operation based on what we just described, if you perform operation the right way, we can directly skip 3 character and continue perform the verification. If now the substring doesn't meet the substring we want to avoid, then we move by 1 character. That is one approach of solving this. That will look like, the implementation will be as follow. So I will have my answer here that I need to initiate as 0, and I need to return my answer here. So here what I need to do is that, okay, I'm gonna start with 0 if it's less than the size of my array, the size of my string, which is b. Yeah, I don't perform any incrementation. What I will say is that, okay, I need to have the string of the sub that will take be the substring of I3, so 3 character from I. So I'm gonna check if sub is equal to 0, 1, 0. Then what we need to do here, we're supposed to say, okay, we increment our answer because we need to perform an operation, and then we'll move through 3 character forward. But if it's not the case, what we do is that we just say remove one character forward. So this will be like this, and at the end the answer will be the number of substring that we need to perform the changes in order to have the string beautiful. So let us run and see what it gives. We have a congratulations, everything is green. Let us submit and see what it gives. Nice, everything is green. So if you really understand how the approach is working behind the skin, you can ask yourself, hey, why don't we just identify the number of occurrence of this substring, and based on that we can have the result? Because we realize that the number of operation we are going to perform will be tightly coupled with the number of substring of this string in our given input. So what we can do is that we can count the number of this substring, or we can just maybe replace all the substring by maybe nothing, and at the end we count the number of characters that has been reduced from the initial string. That will represent the number of blocks that have been removed, and we divide by 3, and it will result in the number of operations we need to perform. So how will it look like? It will look like this. Let us remove everything. So in the previous video, we worked a bit about regex. So we are going to apply the same thing here. So we have a regex with the given string we want to remove in our input. So I'll call it C because I have input B. So I will have regex dot replace. So I should have my input, the regex, and what I want to replace the matching element with. So it will be an empty string. So at the end, this string will have the value of the input without the couple of substring that match this regex. So once I'm here, I can directly return b dot size, which is the size of the initial string, minus c dot size, which is the size of the element after removing the matching character, that I will divide by 3, because the size of the matching character is actually 3. And with this we should have the same result. It is running. Okay, we have everything green. Let us submit. Nice, we can see that everything is green. So that was the ways that I found useful to approach this problem. So if you have any problem, any issue related to what I just described as approach, feel free to leave me a message in the comment section, and don't forget to subscribe and to hit the like button. See you on the next video. Ciao.